Assignment 2.2 focuses on obtaining the parameters of the electromagnetic force equation. When you put the ball on a support centered below the core of the coil, the forces that act on the ball are gravity and the electromagnetic force Fm. The equation that holds the variables that determine the electromagnetic force Fm is shown here. The variables are I, which is the current through the coil, and y, which is the position of the ball. The position y is defined as shown in this scheme. From this it becomes clear that the denominator of Fm is the distance between the top of the ball and the tip of the coil core. Fm will increase when the ball gets closer to the coil core. Fm will also increase when the current through the coil is increased. When taking small enough steps increasing the current, you can get close to the point where Fm equals gravity force. We call this an equilibrium point. Through the user interface of assignment 2.2 and using the three supports, you can gradually increase the current through the coil and find the equilibrium points for all three supports. You will notice that you've passed the equilibrium point when the ball suddenly flies towards the coil core. You can specify the corresponding currents through the user interface. The position y, determined by the support used, and coil current I, where Fm equals the gravity force, is an unstable equilibrium. When you take a support with a different height, there is another coil current that will make Fm equal to gravity force. The closer the ball is positioned to the coil core, the smaller the coil current that makes Fm equal to gravity. When you've determined 2 or 3 equilibrium points, so each equilibrium point defined by a I and Y combination, you can calculate the parameters Cm and Pm of the Fm equation.